Hello guys, welcome to my channel. Today's video is about implementation of ordered linked list. If you have not already subscribed to my channel, please subscribe and promote the content. Singly ordered linked list. This is a simple data structure, dynamic memory allocation. It requires ON space requirement because N is the number of elements going to be stored within the linked list. And this is dynamic memory allocation. This is a linear data structure, linear traversal to access an arbitrary element. The search complexity of the sorted linked list is best case O1, and it happens if the key we are going to find exists on the head node. Otherwise, it is ON. Elements are stored in ascending order. So this linked list will maintain order of ascending order and do not perform any kind of sorting. The order is maintained while inserting new element within the list. Efficient insert and remove methods. Best case is O1. O1 happens when we are inserting or removing the element from the front of the sorted linked list. Worst case and best average case complexity is ON because we have to navigate to the element in a linear fashion. The best case only occurs at the head of the linked list. Thank you guys. Let's begin coding. Hello guys, I have created the project in NetBeans ordered linked list. So I have used the node class from the previous video linked list, singly linked list. This is a very simple node class. It contains two data fields, two constructors. One is default constructor, other one is taking data as a parameter and store it on data field, and two getter methods, one to get data and other to get the next pointer, and two set methods, one to set or update data and the other one is to set and update next pointer or next reference to the next node. Then I wrote the tester class. This is a very simple test that will create the object of ordered linked list and then push the add the element to the list and test the state of the and display the state of the linked list and test all the functions. It is very simple. We add, print the size and print the list, remove, and that's it. This will help us verify the working of the sorted linked list. Let's begin coding in ordered list. This is our ordered list class. I have created skeleton methods. We need size method to get the size of the linked list, is empty method to check if the list is empty, simply print the elements within the linked list, remove method, addFront method. This will add the element at the front of the linked list, and add method. This is a very special method. This method will add the new element at a correct location within the sorted linked list. It locates the location and then insert the new node within the list and maintain the order, you can say ascending order of the sorted linked list. Let's begin. So we start with empty linked list. This dot head is equal to null, ensure empty list at startup, and count is equal to 0. No node at the instantiation time. Okay, add method. Let's do simple method first. Size, simply return count. Is empty, check if the list is empty. Return head is equal to null. And now print. Printing is easy. Start with head node. iterate till end of list. While current is not equal to null, so we print the value and navigate, set to the or move to the next node dot get next. That's it, and print a new line at the end. Okay, now let's do the add function, addFront function. So if list is empty, first create node is equal to new node and value. If this dot is empty, so we simply store head is equal to node, else it means list is not empty, so we make the new node the head node. So we set next to head and then store it to the head pointer node, increase count. That's it. This is our function to add a new node at the front of the list. Now okay, create let's say check two things. Number one, empty list, add to front. Number two, if value is smaller than head node value, so we store to front of node, front of list, sorted list. So if this dot is empty or value is less than this dot head dot get data, so we use this function add front value. That's it, and we return from here. Now the 1 2 is not the case, so case 3 need to insert somewhere between the existing nodes, so we need to trace it. So we create node value. Now we need to move, find correct location. So node current is equal to head, start with head node. Now conditional while to locate the location to insert new node. So while current dot get next is not equal to null, this will run till the end till we reach the last node, and current dot get next dot get data is less than equal to value. Okay, so this condition will run till we find a node that has the same value or we reach bigger value. This loop will exit. This keep iterating for all the smaller and equal nodes. So navigation, move to the next node. That's it. Now there are two cases. Case 1, let's say 4. If we reached last node, if current dot get next is equal to null, this is last node, so we insert it there. So we make current dot set next is equal to node. Okay, and next else, this case is put between two nodes. So node dot set next, current dot get next. Okay, new node next will be the next node of current node. Okay, now set next node of current node to new node. Current dot set next is equal to node. Okay, we are done here, and we update the counter. So this function will efficiently manage the order of the sorted linked list. Okay, now remove function. Okay, first case, if the list is empty, case 1. So in that case, we will print a message. If this dot is empty, S out, the list is empty, and we return from here. Okay, now case 2. We are removing head node. So if head dot get data is equal to value, so we simply set the head to the next node, get next. Else, second case, find the node. Let's reduce the size. Count minus minus. Okay. To find the node, we need to keep track of two nodes. Previous and current. So node current is equal to head and pre is equal to, let's say, null initially. Okay, now iterate to find the node to remove while current is not equal to null. So if we reached desired node, if current dot get data is equal to value, we remove it. So to remove, we shift the next pointer of current node to the next pointer of previous node. So we can skip the current node. So pre dot set next and current dot get next. So the next pointer of current node will be set to the next pointer of the previous node, and we reduce the count, and we break. Now the navigation, your traversal, you can say. So update the pre, set it to the current, and update current to the next node. Current dot get next. So this is our remove function. This will efficiently remove the node in all the cases. So that's it, guys. This is our implementation of the sorted linked list. Let's test it. So this is over. So running it, let's check the output. So we added 4 to the list. Size is 1 and 4 is added to the list. Then we inserted 11. 11 is inserted after the 4. So order is maintained. The number of elements are 2. Then we inserted 10. 10 is inserted between 4 and 11, like here. And we have 3 elements in the sorted linked list. Then we inserted 7. 7 is inserted at the right place, before 10 and after 4. The order is still maintained. Okay, good. Over method is working fine. Then we added 9. 9 is added at the right place. And this is still a sorted linked list. And we inserted 1. It is inserted in the front of the list because it is the smallest number. And this is our order. Now the remove function. Removed 1, the 1 is removed. The remaining list is still maintained. Remove 4, remove 10, and remove 11. Over list is maintained. And remove 7, now the list is empty. Thank you guys. This is the implementation of ordered linked list. If you have not subscribed to the channel, please subscribe and promote the content. And keep watching more and more videos to enhance your skill set. Thank you guys. Have a very good day.